fraction equation can look crowded even when it is only linear. Today, we will make every denominator disappear in one legal move, protect the subtraction sign, solve exactly, and then prove the result by returning to the original equation.
Here is the exact workbook prompt. What value of x satisfies the quantity x minus 6 over 4 minus the quantity x plus 2 over 3 equals negative 11/3?
The answer choices are 14, 22, 18, and negative 11/3. The last choice simply repeats the right side of the equation, so it is attempting copy error rather than a solved value of x.
Before calculating, notice the structure. There are 3 denominators, 4 under the first numerator, 3 under the second numerator, and 3 on the right. A single common multiple can clear all 3 at once.
The least common multiple of 4 and 3 is 12. 12 is the smallest positive number divisible by both, so it clears the fractions without introducing unnecessarily large coefficients.
The crucial word is every. We multiply the entire left side and the entire right side by 12. Equality stays balanced because the same non-zero factor is applied to both sides.
Now distribute the factor 12 across all 3 terms. 12 divided by 4 is 3, and 12 divided by 3 is 4. The subtraction between the 2 left fractions must remain subtraction.
After cancellation, the equation is 3 times the quantity x minus 6 minus 4 times the quantity x plus 2 equals negative 44. No fraction remains, but both group numerators still matter.
Let me check the right side carefully. 12 times negative 11/3 is 4 times negative 11, which is negative 44. Keeping the negative sign here prevents a completely different solution.
Next, distribute into both parentheses. 3 times x minus 6 becomes 3x minus 18. Because the second group is being subtracted, negative 4 multiplies both x and positive 2.
So the expanded equation is 3x minus 18 minus 4x minus 8 equals negative 44. I want to say the constant is negative 10, but that would incorrectly combine negative 18 and positive 8.
Exactly. Negative 18 minus 8 is negative 26. Meanwhile, 3x minus 4x is negative x. Combining like terms gives negative x minus 26 equals negative 44.
To isolate the variable term, add 26 to both sides. The left becomes negative x, and negative 44 plus 26 is negative 18.
Now divide both sides by negative 1. A negative divided by a negative is positive, so x equals 18. That value appears as choice C, but we will verify it before accepting it.
There is a useful reason the sign flips at the end. The combined coefficient of x in the fraction equation is 1/4 minus 1/3, which is negative 1/12. A negative coefficient makes a positive solution plausible here.
Let us verify in the exact original context. Substitute 18 for x before doing any cancellation from our solution path. The first numerator is 18 minus 6, which equals 12.
The second numerator is 18 plus 2, which equals 20. Dividing by 3 gives 20/3, so the original left side becomes 3 minus 20/3.
Rewrite 3 as 9/3. 9/3 minus 20/3 equals negative 11/3, exactly the right side of the source equation. The substitution makes a true statement.
That check does more than confirm arithmetic. It verifies the parentheses, the subtraction of the entire second fraction, and the sign on the right all at once. 18 is not merely an answer choice. It satisfies the original equation.
The source answer is choice C, 18. We have now reached it through legal equivalent operations and independently confirmed it by substitution.
Now for a second representation. Instead of clearing denominators immediately, combine the 2 left fractions over 12. The first numerator is multiplied by 3, and the second numerator is multiplied by 4.
Expanding the numerator gives 3x minus 18 minus 4x minus 8. That simplifies to negative x minus 26, while the denominator remains 12.
The right side, negative 11 thirds, is negative 44 twelfths. Equal fractions with the same non-zero denominator have equal numerators, so negative x minus 26 equals negative 44.
From there, adding 26 and dividing by negative 1 again gives 18. This is not a different answer path so much as the same denominator logic organized into one fraction before the equation is cleared.
For SAT speed, I prefer multiplying every term by 12. It uses fewer written fraction steps. The combined fraction method is still valuable because it exposes the net coefficient negative 1/12 and helps explain uniqueness.
Why is the solution unique? After simplification, the coefficient of x is negative 1, not 0. A non-zero linear coefficient can equal negative 44 for exactly one value of x.
Let us analyze the most common trap. If I write 3 times x minus 6 minus 4x plus 8, I have failed to distribute the outer negative to the positive 2. The correct final constant from that group is negative 8.
A second trap is multiplying only the denominators by 12. That changes the fractions instead of preserving the equation. We multiply each complete term by 12, then cancel common factors between 12 and each denominator.
A third trap is clearing the two fractions on the left but forgetting the right side. Multiplying only one side by 12 breaks equality. The negative 11 thirds must become negative 44 in the same move.
The choices offer a quick final filter, but not a substitute for solving. Negative 11 thirds copies a visible number, while 14 and 22 can arise from sign or constant errors. Only 18 survives direct substitution.
Try a transfer problem with the same structure. What value of y satisfies the quantity y minus 5 over 3 minus the quantity y plus 1 over 2 equals negative 5? Pause mentally and choose the least common denominator.
The denominators 3 and 2 have least common multiple 6. Multiplying every term by 6 gives 2 times y minus 5 minus 3 times y plus 1 equals negative 30.
Distribute carefully. 2y minus 10 minus 3y minus 3 equals negative 30. Combining like terms gives negative y minus 13 equals negative 30.
Add 13 to obtain negative y equals negative 17, then divide by negative 1. The practice solution is y equals 17.
Verify it. 17 minus 5 over 3 is 4, and 17 plus 1 over 2 is 9. 4 minus 9 equals negative 5, so the transfer solution satisfies its original equation too.
Here is the reusable three-step strategy. Find the least common denominator. Multiply every complete term on both sides. Then distribute, combine, solve, and substitute back into the untouched original equation.
For our source equation, 12 cleared the denominators. The outer subtraction produced negative 4x minus 8, and the linear equation reduced to negative x equals negative 18.
Dividing by negative 1 gives x equals 18, and substitution returns negative 11 thirds on both sides. Therefore, the exact workbook answer is choice C, 18.
The lasting idea is simple. Fractions do not make a linear equation mysterious. Clear them with one balanced multiplication, let the signs travel with their entire groups, and always let substitution have the final word.
Optional SAT math study resources are linked in the description. If you purchase through an affiliate link, the channel may earn a small commission at no extra cost to you. As an Amazon associate, I earn from qualifying purchases.